Have you ever wondered if you can be offering a faster, less buggy application experience for your customers? With Raygun Application Performance Monitoring, you have all the information you need at your fingertips to find and fix errors and performance problems across your tech stack down to the line of code. Raygun makes it easy to monitor the impact of your performance improvements, quickly identify and resolve issues, and see how your code performs in the hands of your customers, saving you time, money, and sanity. I've personally used Raygun on my iOS apps, and when a user hits a crash, those crashes get centralized into one location. They get bucketed automatically. I'll get a call stack and an email with a line number where things were crashing. It felt to me that I got a gift for my customer in the form of a bug report that I could actually solve. Head over to raygun.com and try it out for yourself. That's raygun.com for a free 14-day trial. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Nicole Archambault. She's the host of La Vie en Code podcast. She's got a great new Newbie Coder Problem-Solving School course. How are you?
I'm great, Scott. Thank you so much for having me on.
We were planning this podcast to talk about problem solving. And when we were, as with all podcasts, you plan out what you're going to talk about and you think about the different things. And in our email, you said that you bungled a CS degree. Why did you use that word bungled?
That's kind of funny because I don't think I use that word very often. So it must have been the way that I was feeling about it. Sometimes I say I fumbled it or something like that, but I did indeed. I didn't drop out. I went to Wellesley College back in 2003 to 2007. And I started out, in fact, as a computer science major and ended up switching after data structures and algorithms because I've heard after the fact, which I don't like this term either, but people have referred to DSMA as a weed out course. And if that's true, which I mean, by my experience, it might very well be, I think that's awful. But, that basically is a huge part of my story because I had to find a very non-traditional pathway to computer science, which involved me teaching myself web development and kind of going from there.
It feels like there shouldn't be a weed out course. Like the very idea that like people need to be weeded out is kind of weak sauce.
It really is. And having been weeded out, I can tell you it hurts. That set me back so far. And it really gave me the message that I wasn't meant to be there. And as a woman who, according to Stack Overflow, intersectionally, I am less than 0.8%, I think, or maybe it was 0.08. I can't remember. I am African-American, Native American, French Canadian, and intersectionally also I'm on the autism spectrum. And I, insert all the other adjectives I guess I could go by. I'm a big part of a lot of those communities too, with like LGBT and disability advocacy. So yeah, I mean, when it comes right down to it, I need to be there, help me to be a computer science graduate if I'm not, and it kind of ties into what we'll be talking about today because there was stuff I was missing and I wish somebody had given it to me.
Yeah, there's two things there. There's things that you're missing, and then there's also things that they insist that you have. The weed out course for me that almost killed me was calculus.
Oh God!
Which in now 30 years I've never actually used. Like I know that it's important, but it's just not my thing, right? And it just destroyed me. You talk to my wife. I took 11 years to finish my 4-year degree, so I actually only graduated in 2003. But I started my degree in 1992. And it took me 11 years to get it done. And calculus was a part of that. And I busted my butt because it was required for the software engineering degree. And that almost weeded me out. But so I
only chuckle because the first and only course that I've ever failed in my life was calculus. And a huge part of it was just, I also have a nonverbal learning disability, and I talk so openly about all of these aspects of my mental health, mental illness, everything. That's a huge part of me. And I didn't realize how much the nonverbal learning disability, not being able to contextualize things, and it didn't actually have kind of some kind of model to it that my brain could really recognize. And I tried taking it again, and I ended up dropping it and then learned that I didn't need to take calc to begin with for the CS degree. They had actually offered an alternative. So it's like, okay, but yeah, that wasn't a good experience, and it definitely weeded me out. I wasn't planning on going into math, but I'm not surprised to hear at all that you don't use it. I think a lot of the developer and engineer math that we use is, I don't know, I'm not a math person in general. How would you describe it?
Well, like I've had some amazing mathematicians on the show. I've had some amazing 3D graphics people on the show.
Mm.
That is a time for math. That is a great, calculus, I think we can agree, is a useful thing if you can get it into your brain. And if
Mhm.
I were doing those kinds of things in my daily job, that'd be great. But my first job as a web developer was text boxes over data. And, there wasn't a lot of differential equations as I was trying to get data into a text box.
Wow. No, not at all. Not at all.
But the thing that was useful, and I didn't learn it in school, was systems thinking
Mm.
about how to break down a problem. I don't remember ever having a course on that, like how to binary search my way through a problem.
Of course you didn't. And that's actually something that I've recognized. I had no such course either. And I, of course, did not get into the computer science degree program as far as you did. And so I didn't get a chance because of that systems thinking. I didn't
Hmm.
have that. And it really was a massive bottleneck to my education and learning those types of skills. I can imagine they would have only helped me moving down the path to my computer science major. It should have been a 101 course, truthfully, but nobody I really speak to. I was doing a talk at Abstractions last year in Pittsburgh. I think I asked the audience to raise their hands if they had ever had an actual formal problem solving course, and nobody did. Nobody, not a soul. That's disturbing to me. It really is. And that ties into some very personal things that I went through with the CS degree. And, there was a point when I was teaching myself to code that I actually turned around. I wrote a blog post about it, which was kind of a piece of La Vie en Code history, I guess, because I ended up focusing on that. And it was the point in my self education where I realized I needed to bang a UE or something and go back to problem solving. And that I recognized that I was not going to get any further, or it was going to be really painful. And I was probably going to think about dropping off a lot if I didn't actually figure out what I was doing and
Hmm.
why. So the why part is really important. You're absolutely right with systems thinking. That way you have
Yeah.
to know what the binary search is doing, you know?
Yeah. And that blog post is why I'm scaling back on learning to code and ramping up on problem solving. I'll make sure to include a link in the show notes. Um, I think that people find themselves in tech sometimes because they're good at problem solving and they don't know why,
Hmm.
and then they learn to code. But if someone doesn't have that, whatever that I don't know, that brain, that gene, that whatever, that problem solving thing, then they just don't end up learning to code, and then they say, oh well, computers are not for me. I'd
Hmm.
love for people to all feel like they're problem solvers. If we could
Absolutely.
just teach it in schools or teach it in a course.
Yeah, I actually created the first and only completely code agnostic
Mm.
lesson or course, an entire course for it. This just in the past few months, I had released it, and I guess you'll be including some info there. And it was
Hmm.
born because when you search for programmatic problem solving, you will find some stuff, but eventually it's all going to turn into, demonstrating in a language
Right.
or really focusing in not on the language agnostic part. So I really wanted to challenge myself to create. I created another program as well, my coaching in course cohort, career change school, Newbie Coder Career Change School. And it was the same thing. I wanted to really challenge myself to be able to explain these things without referencing a language or a stack. And it just wasn't out there, and it wasn't visible, and it certainly was not 101 level. And I've read a lot of books, but they all seem to go in that direction eventually.
Yeah. And I think that early computer science does do work in pseudocode, but you're right. They drop it very quickly and they go right into a real language. And I think that one could potentially disagree, or one could find that a controversial thing. Like, well, no, you have to get into the code at some point, right? And I
Hmm.
like what you're doing is you're unapologetically saying, well, no, maybe you don't actually have to get into the code right away. Maybe let's just stay in a pseudocode as long as possible so that we don't, lose people in the details of the syntax.
You've got it exactly, Scott. That is my mission at this point, to help people. In fact, what I hope that I can help your listeners understand today is that there are steps leading up to when you actually start writing. I mean, I do some of my problem solving steps right in the code editor. It makes it a little bit easier for me to flesh out.
Mhm.
But there are steps before you actually start writing code syntax. And if you were to ask a lot of people what those are, they might condense it to problem solving, air quotes, which is correct, to figure out your approach to the problem before you actually write the code and face things like syntactical errors and whatnot. The relatively easy stuff to fix, right?
Mhm.
But they don't know how to break down problem solving, as a concept any further than that. And I was able to actually condense it into a set of steps. And there are actually 5 whole steps that I really, very important, equally important steps that I recognize before somebody even starts writing the code, like the program. And people just don't see that. It seems to be invisible, or as you had seen, unnecessary. I had sent you a screenshot too of that nonsense that I got in response to asking some folks if they wanted a podcast guest, to which you obviously responded. But there was another guest that insisted that problem solving was not an actual area to focus on, like an individual area. And I mean, it's ignorant, quite frankly, but it's really leaving a lot. The students need this. So if they're not thinking in terms of what the little students need, the newbie coders,
Mhm.
then, they don't pick up those essential skills either. You can see where they're missing the foundation. And that's why
Mm.
they don't see the importance. These are really foundational skills that I teach. The programmatic problem solving, I've kind of branded myself as tech's programmatic problem solving expert. And then the other side that I look at was another huge struggle in my self education and actually my entire academic life, and that's autodidactism. So the ability to teach yourself and to retain the information that you're learning in a way that you can recall it later and then use that to grow. And between those two things, new coders come in and they flounder and they wonder why they're floundering. And these are the 2 most important foundational skills that I've identified for somebody who is looking to actually succeed in learning to code. So, yeah, that's kind of the origins of where I started to really see the importance of this.
So if they're not retaining this information, if they're not learning how to learn, and if they're not thinking about systems and they're not thinking about problem solving, I think that they still find themselves moving forward in their career, but I see people who are stuck. Basically, Googling is as far as they can go. Like,
Mhm.
Googling is their ability, and then you can go 3 years, 5 years, 10 years into your career, and you can kind of cobble together solutions, but maybe you don't
Mhm.
really truly understand it, but you Googled your way to success. I mean, we all joke about that. We've all joked about how, yeah, I
Right?
wouldn't be a coder without Google. So I'm not shaming people who Google. I'm the original Googler myself. But I'm just saying, though, that like when I started out, we used to write out our algorithms are in comments. That was our
Mhm.
pseudocode. You'd start, we would write no code at all until we understood the problem. Is
Right.
that a part of the process? Really understanding the problem before you start slapping the keyboard and hitting code?
It absolutely is. And I don't know if you want to use that as a segue into talking about the actual steps, maybe that I've broken it down into. I feel like maybe I could run that down
Yeah.
relatively. Quickly, I mean, I've fleshed it out big time into a course where I actually use example problem that I grabbed from Free Code Camp. And it's defined all number, or basically the sum of all numbers. And so I walked through something very basic with them. But yeah, to answer your question, absolutely, understanding the problem is the very first step that I would go. And I have 8 steps overall typically that I walk. I also do coaching for both career changing and for problem solving. I love doing things like group coaching, but this is basically the step that we'll go through. And the first step is to read and understand the problem. Like you said, very first step. If you don't understand the problem, 2 things are going to happen. You're not going to be able, one of 2, or maybe both. You're not going to be able to solve the problem, or you're going to solve the wrong problem. And I've not only seen that, and I mean, I'm not talking about literally like a completely different problem. I'm saying you just don't get it enough to create output that is expected. You're not pinpointing the issue there. So you can see that need to understand and I tell people, read it out loud, minimum 3 times. Read it out loud. Read it until you really get it. Read it until it's stuck in your head, whatever you need to do. But the next step is where you're going to actually make sure that you truly understand it. Do you have any thoughts on step 1? Yeah, I said introducing and understanding the problem, for sure.
Yeah, I'm a big fan of intentional and deliberate practice.
Yes.
And not just letting life and things happen by default. And, you just start running and then you forget about your feet and your feet are just hitting the ground. The same thing happens with the keyboard. It's like, all right, I'm going to do this thing. I'm going to call the Spotify API with Python. And you just start slapping the keyboard and you're like, well, hang on. What am I doing here? And you just spend so much time trying to like IntelliSense your way to success that you didn't actually understand the problem. And then your step 2, which is a thing that I really feel strongly about, which is rephrasing the problem. Because if you can say it back out loud and teach it to somebody, then you probably understand it. So step 1 and 2 are like so essential.
Oh, they go hand in hand, and they are the foundation. You can't do that's the beautiful thing about this. They are literally steps. They build upon one another as they bring us toward a solution that not only works, but is going to be both efficient and effective. I teach very much about measuring efficiency in my course as well, because that comes much later on, but it's still a part of the process. And yep, step number 2 is rephrasing the problem. If you cannot explain the problem in a way that makes sense to you, then even just to yourself, it's going to be an issue for you. And for me in the course, what I had actually done is I had shown, how my brain would best understand. I took a block of text from, a paragraph from Free Code Camp, and I broke it down into clearly what the input would be, what the output would be, and, understanding that each part of this problem can be rephrased in a way that might make more sense to me. That makes sense as is, great. But if it doesn't, then not only understanding, but being able to see it from a couple of different perspectives, I've seen has definitely helped students to understand better what they're going to be solving.
When you need to focus on building, do you want to get bogged down by your database? MongoDB is an intuitive, flexible document database that lets you get to building. MongoDB's document model is a natural way to represent data, so you can focus on what matters. MongoDB Atlas is the best way to use MongoDB. It's a global cloud database service that gives you all of the developer productivity of MongoDB, plus the added simplicity of a fully managed database service. You can get started free with MongoDB Atlas at mongodb.com/atlas. For people who have been coding for many years, who are listening to this, I might think that this is really basic. The reason that you think that this is really basic is because you're doing these steps already. You're just doing them automatically and intuitively. But that doesn't change or de-emphasize or invalidate that they are still discrete steps. You're just doing them naturally.
Absolutely. And that's the beautiful part that I tell people is you're not going to have to be so mindful about this forever. When you're brand new in particular, which is why I made it a 101 level course. When you're brand new, you need to, we face issues like blank screen paralysis is something I've done a podcast episode before on. And that really is experienced when you don't have a clear first step. You come in and you're not sure where to begin. And so you can't build any momentum. And the idea of sitting there stagnant, not having momentum, people drop off at that point. So the idea is definitely to keep them moving forward, and moving them forward to step 3. I explicitly tell them to identify the different components, the important components that are going to be a part of your solution. And there's a lot of good reasons for doing this, but basically you're going to identify your input. So what you're putting in, what you're being given, perhaps even, your output, what's being expected. And so I would actually identify those as both data types. And, so structurally speaking, you can see what you're coming in with. And then you understand what's expected. And variables is something that I think isn't focused on I haven't seen anybody that did it. So this is kind of from my brain. For me, I found when I was solving problems in the process, it was very valuable for me to identify where I was going to be saving things. It's kind of like if you were working through a document, you don't save it every single second. You're not going to assign a variable to everything. But once you've made, significant progress, if that area is important, we do want to make sure to assign it to a variable. And so a lot of these steps are just to get you thinking in the beginning. The first 3 steps are understanding, rephrasing, and starting to think about the structure of our program, where you're going to place things in there. You kind of identify some of your puzzle pieces. And I think that helps, or at least it did for me. Have you seen that type of step defined that way before?
Yeah. And also not to forget implicit inputs, which is, even after all these years, that's the one I always forget. And that's a great one for newbies to remember, is that all the inputs to the function are not necessarily parameters to the function.
Mm-hmm.
I had a really interesting problem that I spent hours and hours and hours on. And it was because one computer was set to English in the US and one computer was sent to English in the UK. And it was an implicit input. And I never thought about it. And until I sat down and I was like, what are all the things that are coming into my world that might influence my problem? And until I'd broken it down and identified everything, basically taken a catalog of everything, I was at the mercy of these implicit inputs.
It's definitely something that needs to be taught as early on as possible. We need to really know what's going in as well as what's coming out. And I don't think, again, none of these steps are really being focused on as much as they should, but that's a huge part of identifying what you're working with in the beginning. Mm-hmm. And you said, we've worked through the first 3 steps by this point. We're still not even writing any code. Step 4 is to break down the problem. Now, a lot of students that I've worked with know this step also as divide and conquer. And if you were to ask somebody, how do you approach a problem? Well, break it down. And that's usually about the only thing that you'll get. And it is part of the process, but it is not the entire process. And one of the examples that I tend to give, and I've used in my course along with a few others, is it's kind of like going grocery shopping, okay? We have the entire process of grocery shopping encapsulated, in going grocery shopping. But so we know what the end goal is, and we've kind of named that entire process, kind of like a function there. Now, what we're looking to do, though, if we're going to break that down, is usually it can take a few passes to really see where to break everything down. But you can recognize that you need to make a grocery list. You need to, it could be as top level at first as go to the grocery store, buy the things, and then go back home. And those are 3 steps. Maybe we can break that down into more. So you need to create a shopping list first. That is really how we know what to do. We could wing it once we get in there, but like a computer with programmatic problem solving doesn't understand how to wing it. So we need to be able, that's really a big difference between programmatic problem solving and kind of the real life problem solving that we face. And then you're going to find your groceries, you're going to check out, you're going to take everything to your car, you're going to load it up, and then you drive home and maybe even put the groceries away, depending on what the problem requires. But that's a hell of a lot more steps than the first three that we came up with. And so with more passes, and you can ask other folks too, I found this very valuable because another set of eyes often helps to see where you might not be breaking things down fully. So this is kind of that divide and conquer step.
One of my favorite, this is random, but one of my favorite programmer jokes, you might remember this one. It makes me think about when you think about breaking down the problem. How do you know that Nicole is a programmer? You send her shopping and you say, get a loaf of bread. And if they have eggs, get 10. And if Nicole comes back with 10 loaves of bread, she's a programmer.
I've heard that definitely before in a couple of different forms. And it does make you think. And that's exactly programmatic problem solving in computers. Really, I explain that everything is on, off, yes, no, true, false. And at every step, we're facing logic flow. So I also cover things like condition. I cover data types, everything in my course, because it is important to know your tools. You have to know what's in your toolbox. But yeah, no, you're absolutely, it's all comes down to, even circuits and binaries just on, off. And beyond that, we can't really wing it or the computers can. And finally, in step 5, you get to pseudocoding this solution. Now, like you said, a lot of people that experienced programmers, they can jump in at, they've already mentally kind of walked through the process leading up to writing the pseudocode. And then they write the pseudocode and, maybe they talk about that, bounce it off a few other developers, heads, or they should, at least, I think, if they're not totally confident in it. And then they go ahead and write the code. And the process of moving from pseudocode to actual code should be as simple as a translation. It should. I mean, what you're writing should not be substantially different in terms of what you're writing in code versus what you're writing in pseudocode, because it means that you didn't quite nail the answer to the problem. And sometimes you have to go back and adjust. It happens really frequently and it's frustrating. And that's usually when you start to think about taking a break, hopefully at least, or, 5 hours later, you'll still be kind of banging your head against it. But yeah, and that leads into step 6 too, where you're going to write your actual code. And that is a lesson where I just offer tips for transposition between the pseudocode and your code, and things to be mindful for in terms of looking up tools that you might not already be aware of that your preferred language has available. So that's also kind of considering, okay, I can do this. Maybe that's a more efficient way of doing this. But if you're making that change, you should also be able to make the same change in plain language in your pseudocode. That's a little tricky move. So you figure out, Python can do this. So maybe I can actually, condense these steps there. Write that out too. Your brain's going to be able to see, okay, well, that's an easier way to do this. And you're more likely, it's an exercise in, like you had said, deliberate practice and deliberate learning. So being able to really reference that is going to be key.
And another interesting thing to think about is that pseudocoding your solution, step 5, writing your code, step 6, if you're in a language that is like the language of your soul, the one you're wired in, as an experienced programmer, I can conflate steps 5 and 6 can be the same. Like I can write sloppy code, but if I, as an experienced programmer, were doing a language in which I have no experience, I would then go back to that deliberate practice, because the code that I would write, for example, in Python, a language I'm not deeply familiar with, is not going to be idiomatic, correct Python. It'll probably smell like C# as if a Python person, right? Like when I speak Spanish, the mistakes I make it clear that I'm not fluent because I'm including English, English structure. So when I write Python, my C# isms sneak in there. So as you move in and out of different languages, different environments, you may expand or be more deliberate in the steps than if you were in a really familiar environment.
Absolutely. So I actually started writing in JavaScript when I was first learning to code. And that was around the time when I got to JavaScript. It started to get more complicated in terms of writing, solving algorithmic challenges. That was when I really realized, okay, well, I didn't realize it at that point. It took me skipping and thinking, oh, well, maybe JavaScript is the problem. And then I went to PHP, and PHP was great too. It offered different functionality compared to JavaScript as well. So I started kind of adapting those ways of thinking. Instead, maybe it's an edge on being able to do something. Well, why? Why is it an edge on being able to do it? Because that's going to make it into your pseudocode and just kind of save another step for you. And again, if you can't do it in your language, you can do it in your, in maybe another language, then, you figure that out maybe when you're writing the code. Just make sure to go back to your pseudocode and actually translate that in. That is the deliberate part of the deliberate practice. So after writing your actual code, at that point, you're going to move on to debugging. And that's kind of, I think, the second step where people who just jump in and kind of flounder, if they don't drown, then they get to the point that something actually works. And they'll jump in, and that's basically their step 2. And they'll be doing that. The thing is that debugging, it really comes down to syntactical issues. And we're not facing, there are 2 different types of errors that you're facing. And either it's unexpected output errors or it's syntactical errors. It's always one or the other. So we've done the work, right, to make sure that we're not getting the unexpected output errors. We've gone through the steps and we understand what we're getting at each step. But the syntactical errors are pretty easy to fix. It's definitely easier to consult with Stack Overflow asking, okay, how do I do this? Or you probably won't even need to find, you won't have to ask a question on there. You'll probably find it already. Versus going on there or just going to the internet saying, how do I approach this problem? So once you've figured out that solution, asking for syntax help is easy. It is. And at that point, you can really debug. And if you did accidentally put yourself in a situation where you solved the wrong problem, you're getting unexpected output, well, this is the time that you can turn around and do it. Maybe it works. You're just not getting the right thing.
And certainly when you understand the problem, when you've broken down the problem, all of this, ironically, makes you a better Googler.
Oh, yeah. Huge skill.
Certainly better than starting at the beginning and Googling from step 1.
It is. And, the approach isn't something you can Google. And we start to get into, I also talk about design patterns. And, I'm big into object-oriented programming. I've done talks on it before with JavaScript. And I love working with objects. And the entire idea of encapsulation really makes a lot of sense to me. But design patterns really exist to solve frequent problems that we find or common problems that we find and will encounter in writing our algorithms. And they're designed to be as clean and efficient and effective as possible. And you'll start to recognize those, as you go along, those patterns. Pattern recognition is really big there.
So where can people go to learn about your course and listen to your podcast?
Absolutely. My course is called, so the name, I actually have a little suite of courses that I'm just kind of fleshing out with my final course. But it's called Newbie Coder Problem Solving School. And the actual original, the overall school that I have is Newbie Coder School. And it's for people who are looking to learn those super foundational skills from a code agnostic standpoint. So if you were to go, my website is at lavioncode.net, and Scott will have that, I'm sure, on the website. And you can find my podcast as well on other iTunes or Spotify. I have it on, and I think Stitcher. I pulled it down off SoundCloud because they wanted money from me. But we got in those locations. And also I have the episode pages up on my page as well. So I try to cover all the bases, but you know, it makes it a little bit more complicated too. But yeah, my course, you'll see on the top there, there's a course section in the drop-down menu, and you'll see Newbie Coder Problem Solving School there. Instant access, obviously. It's a great course. I have gotten such phenomenal feedback on it, such great testimonials, and I'm so excited to be helping people with what I've learned, because out of necessity, that ties into my whole story.
That's great. Well, thanks so much for chatting with me today.
Thank you for having me again, Scott. It's been great.
This has been another episode of Hansel Minutes, and we'll see you again next week.